AP Statistics video for Chapter 3 and 4. AP question. It says, each of 25 adult women was asked to provide her own height, Y, in inches, and the height X in inches of her father. The scatter plot below displays the results of the adults. Only 22 of the 25 pairs are distinguishable because some of the XY pairs were the same. The equation of the least squares regression line is y hat equals 35.1 plus 0.427x. A wants us to draw the least squares regression line on the scatter plot above. Well, we can do this without doing much work at all. It gives us the line, but we also notice that the intercept of the line, 35.1, isn't on this graph. So what we're going to do instead is plug in some numbers that are on this graph and graph into the equation and graph our line. So we're going to start with 62. We're going to plug in 62, so we're going to do 35.1 plus 0.427 times, oh my goodness, 35.1 plus 0.427 times 62, and we're going to get 61.574. I'm going to go ahead and write that down. Or I've already written that down right here. Then we're going to plug in 66, 35.1 plus 0.427 times 66. We get 63.282, written that down too. We're going to plug in 70, 5.1 plus 0.427 times 70. 64.99. Let's do a couple more. We can do 74. We get 35.1 plus 0.427 times 7. We get 66.698. And one more, we can do 78 plus 0.427 times 78. And we get 68.406. Now we can take those little points and we can graph them on our actual line. Or graph them on our graph and draw a line through them. That's our least squares regression line. So we have 62 right here, 61.574. That'd be about right here. Then 66, 63.282 would be about right here. 70, 64.99, about right here. 74, 66.698, be about right there. And then 78, 68.406 would be about right there. And then we could go ahead, we could draw a line through the points we solved for, and that's our least squares regression line. B asks us, one father's height was x equals 67 inches, and his daughter's height was y equals 61 inches. Circle the point on the scatter plot above that represents this pair, and draw the segment on the scatter plot that corresponds to the residual for it. Well, let's find x. We know 67, so 2, 4, 6, 7. Oh, this looks like the only one on that line. So here's that point, and draw the segment on the scatter plot that corresponds to the residual. So, oh, that's just like that. Now we need to find the residual. So we need to do actual minus predicted. So we know our actual y value was 61. So we're going to have, what is right here? We have 61 minus the predicted. We need to predict it. So we need to do our equation, plug this x into our equation. The x was 67. And we get 63.709. Now we can do that in the calculator. 61 minus 63.709, and we get negative 2.709. This negative number means that it was below the least squares regression line, just like our dot is. Perfect. That's our numerical value for the residual. That's a little far off. Our r squared must not be very high. C says, suppose the point 84x and y equals 71 is added to the data set. Well, let's graph it before we go any further. So 80, 82, 84, and then we're going to go all the way up to 70, 71. Oh, that's about right there. The question wants to know, would the slope of the least squares regression line increase, decrease, or remain about the same? Well, if we zoom in on our graph a little, it looks like that's right about on that line. So I would say the slope would stay the same because it's not really significantly above. It's going to make the line tilt and lean towards that one. It's not really significantly below that's going to make the line tilt. It's pretty much right on that line. It might be on that line, and that would keep the correlation and the slope the same. Or not the correlation, just the slope the same. D says, would the correlation increase, decrease, or remain about the same? Explain. I think that because the dot is so close to on that line, probably on that line, the correlation would increase. Because the more dots you have on that line, the closer they are to that line, then the higher the correlation is. And that dot is right on it. Or really, really close. So that's helping out our data, making the correlation better.